Hello, everybody. Welcome to our session today. We're here with Chris Dasgupta, sorry, one second, my audio. He'll be presenting for us today, and we're excited to hear from him. Thank you.
Thank you, Kyle, and hello, everyone. This is great to see all of you, and I hope this is going to be a great session. So we are going to talk about FHIR in the whole, and the entire title, like if you look into it, it reminds of the entire construct, like, oh, there is a FHIR in the whole, like, what's happening, and there's so much to do, right? So I work in the healthcare domain along with Dr. Julia Hitzberg. We are building a startup which is called TrialBridge, and we look very specifically on clinical trials and patient discovery. But for that, one of the things that we have understood is that when we look into healthcare as a structure, as a data, there is a lot of demand for transforming like FHIR records into semantically linked nodes. So what are we going to do? First of all, right, like when we say graphical, like clinical data from FHIR records. So what is FHIR? FHIR is fast healthcare interoperability resources. And anything which works on healthcare, they actually work on FHIR data. These are like, the standards, and these are global standard that has to be there across all EMR and EHR. So anything what you do has to go through this record structure. And these records are very resource-centric, and they often fail to capture the complexity. And we are going to show you, because this entire session, what we have, we're going to also look into each of the integrities of how exactly a FHIR record looks like from a patient perspective. But for each of it, we also look into that what could be the underlying relationships and the context of a patient journey and during the development, which can be hindered when it comes to a true AI-driven clinical system. Now, over the years, what we have seen is people have been playing with, like in clinical nodes, they have created NERs, and that's what we also used to do, like when we are developing the systems. And we thought that, okay, what could be a better way to do that, right? Like, can we just have when we look into NERs, and if you remember name entity recognitions, the idea was that you process an entire text and try to identify an NER, and from those NER you can actually look into clinical node, be it like disease or a condition or anything. But then we thought that if we are doing this, why don't we create them as a node and then create a relationship between them so that we can have a better, strong relationship between patients as well as between the systems or among the systems that we want to talk with the patients. So we thought to build something called W.H.O.L.E framework, which constitutes of workflows, hierarchy, ontology, linkage, and encoding. We are very specifically looking into graph neural nets, RAG, and LLM-driven agentic framework. But while we do that, our complete focus is also on the open source. So whatever you're going to see as in the demo as well, because we'll try to show you a quick thing, every single thing is built on open source, and we are using the Neo4j Community Edition and the graph per se for that. But apart from that, language models, we have a fine-tuned DeepSeek and a fine-tuned Qwen on which we are going to show you the demo. So a normal FHIR record is not very structured like this, but let's say it has this kind of a profile, like you have a name, you have a date of birth, you have conditions. Now, what you see over here is like pulmonary emphysema, which is a respiratory kind of disease. Then you have another disease, let's say a prediabetes and the chronic sinusitis. These are codes, what we call as medical code. This could be any code. This could be right now it's a SNOMED, or it could be like a MEDRA code or any kind of medical coding. So any patient data has to be encoded. And sometimes the patient data is not coded properly. Sometimes the patient data just sits in one code, and there the problem becomes, because if you want to create a cluster of patients.
Hey Chris, so sorry to interrupt, but you're not sharing a screen. So if you want to share something, nobody can see your screen. So maybe do that again, or start doing that, because otherwise it's going to be difficult to follow. You know how to do it? Yeah, here we go. Perfect. Thank you.
Perfect.
Oh, okay. Sorry. I'm so sorry. So again, I did not see that like I'm just looking into my screen. I did not see that it was not sharing. Okay, so back to it, right? Like, so we are talking about FHIR. So FHIR is like, as I said, fast healthcare interoperability source. And what we have so far done is to create a solution which is based on graph. And for us to talk about the whole framework, like firing the whole, we are looking into workflows, hierarchy, ontology, linkage, and encoding. So when we say about it, we are also thinking from a perspective of that how graph neural networks or RAG or anything on the LLM agentic framework can work together. And when we say LLM agentic framework, we are not just using one. We are using multiple models. We are using all the open source models. And this entire structure is actually built on open source. So, okay. So FHIR record in per se is not this structure. So I'll show you a real FHIR record. And at that point, I hope everybody is able to see my screen because I cannot, I'm actually sharing my whole screen, right? Okay. So for FHIR record, when we look into it, so we have like a patient profile, a patient name, like a date of birth, condition. Now, these conditions, when I say, for example, pulmonary emphysema, this is a respiratory disease, and these could be yours, like codes which are SNOMED or MEDRA or ICD code. These are like certain codes where, like you map and match patients together. Now, when we look into care resources, these are the other things when we say, like, these are like from an encounter perspective, that what could have been the encounter, what is the last encounter that is there, for this patient has died already. What was the care plan that was there, and if it is active or not, right, and why it is active. There are ways, there are a lot of things which happen on the FHIR record. These are just like, records which are already there. And then what was the last therapy, or what was the last therapy which was part of it during that care plan. So it was a smoking cessation therapy or a home oxygen therapy. The thing is that when you have to cluster these kind of patients together to understand that how many such patients are there, and these patients has to be mapped to some clinical trials or any clinical decision network, becomes very, very, very tough. So what we did was we thought of creating workflows. Workflows is you map the diagnosis, you create a treatment out of it, and then you think of outcome sequences. You visualize temporal dependencies between events, and we also looked into coding pathways and optimization. So when we say coding pathways, we standardize the clinical coding sequence. So when I say clinical coding sequence, I'm going to look into it just in the next way. And on that, we try to detect that how proximity-wise they are close to each other. And when we say close to each other, not the semantic understanding of closure, like what is the similarity onto it, but as a disease, on a disease tree, if you look into it, how close is that symptom to the other symptom? And when you try to create a similarity between two disease or two symptoms, that is where the graph plays a very, very important role, because then you can look into weights and understand that they are very similar to each other. So maybe the person who is having one symptom and this symptom, they actually fall into this particular disease. And that's where we enable an intelligent, we build an intelligent routing on that. So on this, when we say hierarchy, so when we say, firing the whole, the H stands for hierarchy. So this is what I was saying. So if you look into it, we have system organ class. So this is a MEDRA map, and this is what we call as an ABCDDD. This is by WHO. Now, imagine this, a person who is having a kind of feeling, like quasi, they will have nausea, but then again, it is part of a symptom, which is nausea and the vomiting symptom. And then again, this is part of gastrointestinal signs and symptom. And at the end, it could be a gastrointestinal disorder. normally a patient comes with just when the record is being stored, or when the patient say that, I have a nausea, you normally just say I have a nausea. You never go to the doctor and say that, hey, I have a gastrointestinal disorder kind of disease or a term or like that, right? So normally the data stores at this level. But ideally, when you want to map from over here at a larger level to other patients, you will need a SOC level of class. The same way when we look into drugs, because this is a kind of hierarchy of a drug, like for a specific drug, when we say there is a certain drug class which happens. So at the top, you have like the anatomical group, then you have the theoretical subgroup, then the pharmacological group, and then the chemical subgroup, and then the specific drug. And if you look into all of this, this creates some hierarchy for us. And that's where we need a lot of insights to it, that how it works. That's where we look into the ontology, which is the whole of O. And on this, we want to say that, okay, when we say clinical meaning for it, for example, the SNOMED CT connects to hypertension, comorbidities, medication, and diagnostic. In that, when we say we have certain semantic coherence, when we say that there are different system and organizations, these are basically healthcare system and healthcare organization. The same way, this is more of a medical knowledge, but when you look into from a perspective of how inference and reasoning work, you need an AI to work onto it so that it works on the graph embeddings and everything. At the same time, you also have to look into the interoperability part of it. So that's where you have to make sure that it works on the FHIR record, right? Because just like you do not have any normal standard that just throw it into JSON or XML. You have to have a very specific format of the data to connect it to the EMR or EHR systems. And then this is the linkage, where we are going to talk about the graph construction. So for each of the patient, when they have an encounter, we call it as a node. If the condition has a medication, we say that as an edge. And for each of the observations that we have, let's say if the patient had this disease at this point of time for this much time, we call it as a temporal metadata, where the relationship occurred and changed. And finally, the encoding. This is again the clinical encoding that we're looking at, which is basically the different encoding that we use in our system, the SNOMED, LOINC, the ICD, and RxLong, which is for the indication. Before we go to the actual demo and show you what it is, I want to show you the actual demo and show you that this is how the graph is working. A quick thing is that these things actually works on a clinical decision support or on the agentic workflows. Now I'm going to show you a flow of agent that I'm doing it. Now for this agent, what we have done is we did not create any kind of, we did not use any agent workflow. We created our own agent framework, and we use the entire model of decentralized compute. So each of our agents are working on open source, on direct container, which has their own GPUs, and we just move the course of action to those particular containers. The relational graph that we are looking at is somehow like this. The patient node, and the patient, they have an ID, they have a gender, a risk, they get diagnosed with something, you have a condition node, then you have a medication node as well. And in the medication node, you have certain information which says code, drug, dose, or adherence. Now, the graph intelligence, this is where the entire traversing works on. So we'll go to quickly on this, the agentic framework. As we look into it, there are multiple agents that we are working on. There are totally we have building 12 agents, which is working completely on these. But today we are going to see 4 of them working together for one. So one is the diagnosis agent, and it doesn't really create a diagnosis, but it actually traverses and shows you that this could be a proper diagnosis onto it. The risk assessment is again when we run our GNN prediction and we say that, okay, these are the graph neural networks, and based on this we create our GNN prediction. The treatment planner looks into the FHIR data and say for these are the drug interactions, that how many drugs have been taken or given to it, and the documentation agent will help people to identify and pull the data from that and say that, okay, if there is any insight into it, I want to use it as a documentation agent, which is again like in a FHIR compliant per se. The terminology again, before I run into FHIR condition, we normally use SNOMED CT, which will display you something like this during the demo. The ICD is mapping the code. Each of these ICD mapping, they can have a hierarchy, and that's where this is very important. Like FHIR has a hierarchy, SNOMED has a hierarchy, ICD has a hierarchy, METRA has a hierarchy. But the bigger thing is that what is the most important thing is that each of these nodes, they connect to each other. Sometimes you want to understand that the EHR systems, which are sitting right in a hospital, they operate at at a different medication or medical coding level. And while the provider or the patient organization or the patient data is sitting in a different level of coding. So how do you map to each other and create an entity onto it? And this way we create a cross-system link where we say that, okay, if it is mapping to a MEDRA LLD or an ICD-11, we create a SNOMED to link map and say that there's a semantic similarity between those. And then we look into the event mining, because each of the data, each of the patient record, they have a complete drug event or a condition event mapping to it. And that's where we look into that how patient cohorts can be formed based on cross-functional or cross-sectional data, but yet they work as one front itself. So this is where we want to see something. So I want to quickly give you an overview, and then I switch to the actual system. So I'm going to show you two systems. We have quite some time left already. So first is something like this, which I'm going to show as a chat interface. So as you look into it, I'm going to have multiple agents, which is ask, intent, fetch, aggregate, understand, answer. And this is part of the entire, like the whole framework. Now, whatever you see over here will be the graph which gets generated. And this graph is generated from the data which I'm going to show you, but it's like very thorough. The FHIR data is very long, and it has a lot of information. So I have like pre-run it. So I want to show you that how exactly the data comes out. But the good thing is when you have it, it actually, when we look into it, it will say that, again, how many patients are suffering from cardiac disorder. It will say that, okay, match a MEDRA SOC. So MEDRA is, again, a clinical coding system organ class of cardiac disorder. And I'm saying cardiac disorder, and then one patient met the criteria. So before that, let's quickly go to this. Yeah. So I think everybody can see my screen, right? So over here, what I said is when I have already run that I want to show you that this entire thing is running on in a private compute. And for each of it, when it runs these agents will just check that how much time does it take. So for the entire latency, it is around 28,000 milliseconds, because it was taking a lot of time for generating the graph. But then again, the intent takes about 3,000 milliseconds, and then answer takes about it. Now over here, before that, what exactly the intent passed? So when we say, show me the patient who was suffering from cardiac disorder, what was the intent which was passed over here? So if you look into it, it directly went and created a task, and they said that, okay, I have to find patients. Now think of this way, you can create, this is exactly the taxonomy or structure that you can fuse your own NCP plugins onto it. And you can actually do that, right? So intent is something where you create an intent and say that, okay, I want to find a patient, and my taxonomy should be on MEDRA, because for me, the lowest level terms, the most of the terms appear in MEDRA. And let's say, okay, I want to find for cardiac disorder, right? And they have no filters onto it. And then what was the search result? So it says, okay, I found it by SOC, and this entire data is sitting in Neo4j, by the way. And the patient is in this ID, the patient name for that with the ID, and they have this particular disease. So when the disease comes in, then it passes on to the record JSON. And over here, I get to know that, okay, the patient has all this disease. Now, if you look into it, we have multiple disease which says, the PT. Now, for example, this is where the graph is working and giving out the data point for us, right? So if you look into it, this is where we say that why the graph said that it is a disorder. So for example, I say cardiac disorder, but this is an SOC, and normally the patient record is not put with that. They have a patient suffering from syncope, but then I know that there is a relationship between PT and SOC, And even if not there, if a patient was only tagged with SNOMED, it will automatically tag with this PT and thereby this SOC. So what you see this is like a complete end structure which gets generated for the patient and say that, okay, these are the certain conditions or these are the certain diseases that they have found. And there are multiple data points from a FHIR record. Now, if I look into the documents which are there, then there are other structured preview of the documents which are coming in, because for other patients or like relational patients where you see that, okay, if a person had something similar to it, which can be mapped together for those patients are into these cluster of the patients. So this is where we find out that which are at a a weaker like weight or weaker link, and then we can look into relational entities on top of it. So when I look into it, so when I say this, it says match MedRI SOC cardiac disorder, one patient met the criteria, PT is involved, aortic aneurysm, attention deficit hypersthetic disorder, syncope, emphysema, and carbohydrate tolerance decreased. Now, when I say it, 5 related document snippet also included, which I showed you. This is the agent activity. Now, for the graph notation, if you look into it, right? So let me show you one quick thing over here. So so this is an investigation node. And when I say this is a carbohydrate tolerance decrease node, but at any point of time, when I look into, like for the patient, I can see that how this patient have been part of a document. And when I say document, these documents are the finding documents that, what are the other finding documents. And then for each of them, we can find out. For example, my question was on cardiac disorder. So, okay, this is vascular. There has to be a cardiac disorder. I think this is respiratory. Chronic sinusitis. Yeah, so if you look into it, the cardiac disorder. So the patient was reached with this node via syncope, and syncope, if you look into it, can be a part of cardiac disorder, or it could be a nervous system disorder, or it could be like a vascular disorder. So when you look into these kind of things, and if I go over here, I can directly see that it was a condition that was from the patient. And if I look from the condition, and if I go all the way, I can find that the condition is directly, if you look into it, the condition is directly mapped to the patient, right? So the patient is over here. So this is where we see that the relational entity. So even though I am sending a simple chat, it was able to go through all the agents. It was able to run these agents independently, the graph agents separately, understand the intent, process it, throw it to Neo4j, and then generated a proper graph. And I have the proof that yes, this person actually has a cardiac disorder. And this is what I actually showed you right now. So a very quick thing. This was all from the FHIR in the whole demo, but a quick thing also, which is going to help you understand that how, when I say that semantic, and when you look into semantic understanding and also create graph nodes out of simple, clear text. So let me show you something. This is what we call as like a trial. So when you look into clinical trial, this is the FHIR JSON data that normally is used for matching, clinical trials or to match clinical trial with patients. So when we look into clinical trial records, this is the kind of record that you get, the FHIR JSON, right? So if you look into it, this is extremely detailed, but at the same time they follow whatever structure they want. They have only SNOMED structure, and sometimes they will just have a condition or anything like that. So what do you do out of it? So what we did was we created something called FHIR, and based on it, we create a FHIR framework onto it. But I will tell you one thing, which is the biggest important thing. If you look into this particular section, which is out here, is completely text format data. Okay, so this entire thing is basically a text, and it cannot be directly converted into it. For example, the SBP has to be greater than 140 and less than 180. How do you convert it into nodes and semantical noding? This is where we used our own concept of using a graph rag on top of it, and then we say that, okay, if I want to break down even a sentence, I was able to break down based on these classification, and also create our own numbers so that I can directly do a number mapping, and I don't have to use an LLM to process an LLM node. But then the biggest comes in that what we showed you, that the patients which are over here, what we do with the patients. The person is already having a condition, so what next? How do you use it? This is where we create something called graph. And for example, from the same data, if a criteria has an indication criteria, and then from there we say that, okay, if a person is having some kind of disease, some kind of condition, they will be mapped to this condition. And this condition will give you mapping to all the other, like this is for just one trial, but this will give you a condition to all the other, patients, all the other graph. So we showed you two individual graphs, but the ideal way is to connect both of these graphs. And that is what we want to do using a common connector between FHIR in the whole and the clinical trial explorer. So I think that's all. I'm happy to take some quick questions. Oh, my Yulia is also here. So if Yulia wants to come over. Okay. Are there any questions over here? I'm actually looking into it. Okay. Any queries? Any question? Varun Mathur, will you be sharing the code for this demo? We can share the FHIR in the whole code because we are trying to open source a graph code completely. So we are going to write a paper and open source the entire code and the paper so that it can help the community. But only for the FHIR in the whole that we are building. And honestly speaking, it's actually very important that we should use local LLMs, because one of the aspect of healthcare, what we understood is that it has to be very private. So rather than taking everything to closed source, it's important that you bring everything to open source in the premise, and that's where we want to do it. And this entire thing was hosted in a self-hosted environment, which was running with a cluster of 3 Linux machine, 16 GB GPUs for each of them. So yes, Nan, so we are using 3 models for the clinical side of it. So one is a fine-tuned model on DeepSeek, another is a fine-tuned model of Qwen, which is again a multimodal model. And then we also have our own RAG, which works on top of Llama 3.1, basically. And it's an 8B model. So all our 8B and 7B models. And for intent, we are using Gemma. So where you found out how the intent classification. So anybody who's building a MCP, make sure that you use a small model for the MCP plugins or even for the intent. That's the best thing to do. You have another 15 seconds here. Okay. I hope that that's a great wish to discuss. Thank you, Harshit. Thank you, Nan.